Hello. Welcome to the second session of permutations and combinations. Let's look at the permutation first. So, permutation refers to the arrangement of objects or elements in a specific order. The order of the arrangement matters, meaning that even a slight change in the order of the elements will result in a different permutation.
Let's take an example to illustrate permutations. Suppose we have three colored balls, red, R, white, W, and blue, B. We want to find all the possible permutations when arranging these balls in a row. The three balls can be arranged in 6 different ways. The first arrangement is red, white, blue. The second arrangement is red, blue, white. The third arrangement is white, red, blue. The fourth arrangement is white, blue, red. The fifth arrangement is blue, red, white. The sixth arrangement is blue, white, red. Each arrangement represents a distinct permutation. Notice that changing the order of the colors creates a different permutation.
If we had two red balls, for example, we could differentiate them by labeling them R1 and R2, and the number of permutations would increase accordingly. In general, the number of permutations of a set of objects can be calculated using the factorial function. In this example, since we have three distinct balls, we calculate the number of permutations as 3 factorial is equal to 3 multiplied by 2 multiplied by 1, which is equal to 6. Therefore, there are 6 different permutations when arranging the three colored balls R, W, B in a row. It's important to note that as the number of objects or elements increases, the number of possible permutations grows rapidly. Permutations are widely used in various fields, such as mathematics, computer science, statistics, and cryptography.
For more updates, follow the FT World on Instagram and subscribe the FT World on YouTube.